Welcome to Anu Online Tutorials. This is Anusha with a new video today. If you like our video, please subscribe, share to your friends, and don't forget to click bell icon. So let's start our topic now. Our topic is about chemical equation. So first, there are different types of changes. You have learned in your previous classes, isn't it? There are different types of changes. One of the changes are physical change. What is a physical change? In physical change, the matter is changed from one form to another form, but no new substance is formed. That is a physical change. Like crushing a can, heating water are physical changes. Next, what are chemical changes? Chemical changes are those in which new substance is formed, which can be same as the substances participated in the reaction or different of substance participated in the reaction. A new substance is formed. That is, you can say product. Like lime water, if you mix with water, if you mix, it becomes lime water. It's a chemical change, isn't it? It does not look like a lime, or it does not look like a water. Some completely different thing has come. Like magnesium ribbon, when you burn it in the presence of oxygen, if you burn, then an ash will be magnesium oxide will be formed, which is different from, it does not look like a magnesium. Isn't it ribbon? It does not look. It gives us something different product. So these all are the chemical changes and physical changes. There are some permanent changes, there are temporary changes, isn't it? In this lesson, we are going to learn about chemical reactions, what takes place, and how they are chemical reactions taking place, and how many types are there, and how chemical reactions See, take quicklime, that is calcium oxide, and water, and take one beaker, add quicklime or calcium oxide into this, with that water. If these two get mixed, a new substance is going to come out. If you touch this beaker, after the reaction, it becomes heat. You can feel it is heat, isn't it? It is hot, you can feel. That is called as, when chemical oxide is combined with water, calcium oxide plus water gives rise to what? Calcium hydroxide, which is different from these two. So here what happened? This is the first example I am taking in chemical reaction. First example, what happened? The heat is evolved out. This new product is formed, which is different from these two. And next, our second example is sodium sulphate and barium chloride. When you mix these two aqueous solutions, these two are aqueous solutions. When you mix these two, sodium sulphate, Na2SO4, barium chloride, BaCl2. When you mix these two in a beaker, you need to mix these two, barium sulphate and barium chloride and sodium sulphate. Now, if you add these two, what you are going to get? sodium sulphate plus barium chloride. Barium chloride. What you are going to get? Sodium sulphate plus barium chloride. Then after the reaction, you can see barium sulphate plus sodium chloride. Sodium chloride means, see, in the beaker, when you add these two, sodium sulphate Na2SO4 plus BaCl2, barium chloride, if you add the barium chloride, the barium sulphate is formed, which does not mix with this solution, and it goes to down as a precipitate. Means the thing which is down. In your tea also, when you put your tea, when you put tea for some time, after taking that decoction, if you keep that tea like that only, what happens? The tea, the heavier one, which does not mix with the water, will go down and the water will come out. That the same precipitate which is formed down. And another, what is there? Barium sulphate over sodium chloride. What is that? Sodium chloride. Sodium chloride now will mix with the water. Sodium chloride will mix with the water. Now crystals and HCl solution. Take one beaker, put zinc crystals, add HCl to this. After some time, a reaction takes place and some fumes of gas will be coming out. And if you test that with a matchstick, the gas will put off the matchstick with a pop sound, which indicating it is an H2 is coming out, hydrogen is coming out. So from above these three, what you can learn? From first, second and third example, what you can learn? In the first example, what you can learn, when two calcium oxide plus water both reacted, a new substance has been formed, which is different from new substance formed, which may be different from, which may be same or different from the original one. New substance is formed. Next, in second one, which are, and from the first one, another thing also you can learn. Heat energy is given out. So it is called, when heat energy is given out in a reaction, it is called exothermic reaction. When heat energy is taken, it is called as endothermic reaction. How can you know whether heat energy is released or not? You can't see the energy, isn't it? But if you touch the beaker, you can feel it is hot. And third, new substance is formed, exothermic and endothermic reactions. And third one, a gas may be evolved, isn't it? Gas is evolved out. These you can learn from the above reactions, isn't it? Now, see, when I want to write, see, if I want to write the reaction, if I write like this, when calcium oxide is reacted with water, then a new substance, calcium oxide, is formed. This is a big way to write. You don't feel it, I feel it. I'm very lazy to write this much big one. So to make it short, you can represent in the form of a symbol. You can write like this first. Calcium oxide plus water. gives rise to or yields to calcium oxide. I feel this is also so Hindi. Okay, I'll tell you how to write it. First, see, these two substances undergo reaction, isn't it? These two substances undergo reactions and form a new substance. These two substances undergo reaction and form a new substance. The substance which participate, which combine or which react are called reactants. What they are called, ma? They are called as reactants. What they are called? Reactants. And the substance, after these two mixing or combining or reacting, a new substance is formed. This is called as product. What is this? Reactant. What is this? Product. So on the left hand side, the substances which combine to form, undergo some chemical reaction is called as a reactant, and the final one which is formed, the substance, is called as a product. This is reactant and this is called as product. So the reactants always will be given in the left hand side, and the products, the final one which is given, it is given with the right hand side. And in this, in spite of writing like this, still an easier method you can write in the form of a symbols. CaO plus H2O. CO is nothing but calcium oxide reacted with water to form what? Calcium hydroxide. So let go here. Calcium hydroxide it is. Calcium hydroxide. Calcium hydroxide. Calcium hydroxide is formed. What is formed? Calcium hydroxide. CaOH2. CaOH2 is formed. Now, I am telling you, wait. When a calcium oxide is reacted with water, the new substance, what it is formed? Calcium hydroxide is formed. Calcium oxide plus water will give rise to calcium hydroxide. This is the reactant side and that is the product side. These two are reactants. These two are reactants. And this is called as a product. This is a reactant. This is what? Product. This is what? Reactant. This is reactant and this is product. Now, what is a chemical equation? Chemical equation is nothing but representing the chemical reaction. Representing the chemical reaction in the form of a symbols or writing symbols or molecular formulas like this. It's a molecular formula, calcium oxide. Calcium molecular formulas. This is nothing but your chemical equation. In this chemical equation, let me tell you some important points what you need to remember. What you need to remember. So you know now, the shortest form to write is this chemical equation. Something you are equating some reactants to the products. Now, let me give you some more, let me introduce you some more important points which are very, very important, and what you, the terminology is what you call. So, CaO plus H2O gives rise to CaOH, calcium hydroxide. So, this is what if something is written here, these are called as subscripts. These numbers are called as subscripts. H2 plus O2 gives rise to H2O. Balancing and all we will see. First listen to this. This is called as what What it is called? It is called as subscripts. 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 It is called what? Subscripts. These are called what? Subscripts. Okay, here subscript is 2. Here nothing is there, no? If nothing is there, it means it's 1. If nothing is there, it means it is 1. If something is there, that will be it. How many atoms of calcium are participating? Only 1. How many atoms of oxygen are participating? 1. Here 2 hydrogen atoms. Here 1. The molecular formula. This, see, how many are participating? If I write here, suppose, example, you should not write like this. Example I am saying. If I write something here, 6. So this is a molecule, isn't it? How many molecules of CaO is participating? This will tell. It is called as coefficient. What it is called? Coefficient. In front of molecular formula, if number is there, it is called as coefficient. What it is called? Coefficient. I will show you in previous formula. See, H2 plus O2 gives rise to H2O. Isn't it? Here 2. And here 2. Now, how many hydrogen atoms are participating means 2. It's a coefficient. What is called? Coefficient. For this. So what you need to do when I say how many hydrogen atoms are how many hydrogens are participating in the reaction means 2 into 2. 2 into 2, 4. What is that? 2. You need to multiply with the subscript. Here nothing is there, coefficient. It means it is 1. 1 into 2, 2. Here 2 into 2. 2 into 2, 4 hydrogens. 2 into 1, nothing is there, isn't it? 1. 2 into 1, 2 oxygens. Like this you are supposed to. These are called as coefficients, these subscripts. And this arrow mark is nothing but it is called yields. It is called yields. It is called yields too. Now, writing the formula. Okay. When you are writing the formula, you need to remember one thing, that according to the law of conservation of masses, the number of atoms which are there in the reactant side should be equal to the number of atoms which are there in the product side. Suppose CaO plus H2O, which gives rise to CaOH2. How many calcium atoms are there? Only 1. 1. This is reactant side, isn't it? Those many calcium should be only there in the product also. Here also 1. Done. Oxygen. Here 1. If nothing is there, I said na, for the subscript, if nothing is there, it means it is 1. Here also O is there. Nothing is there means it is 1. 1 plus 1, 2. Here, this O, this 2 belongs to this O also. 2. So oxygen 2, done. Hydrogen 2, 2 done. And so here you see H2 plus O2 will gives rise to hydrogen plus oxygen will gives rise to water, you know. See, here nothing is there, coefficient. Nothing is there. It means it is 1. 1 into 2, it means it is 2. 1 into 2, 2. Here also. Nothing is there. 1 into 2, 2. If here some coefficient is there, it belongs to this and this both. But here nothing is there. So, hydrogen is 2. Oxygen is 1. Oxygen is 1. So, what? According to law of conservation of mass, I need to balance number of how many atoms are participating in the reactant side. Those many should be there in the product. You should not, in the product side, the atoms should not get reduced or the ratio should not get reduced, isn't it? So what you need to do? You need to balance this. If I want to balance this, If I want to balance this, these are called subscripts, I told already, isn't it? If I want to balance, you are not supposed to touch the subscripts, and you are not supposed to add to the subscripts also. You are not supposed to add to the subscripts. It's a wrong way of adding to the subscripts. You should not touch the ratios of atoms. You are supposed to wear whatever you want to balance. You want to balance it. Something, isn't it? Then you need to add to the coefficient. Where I need to add? You are wrong. They will put it in the jail if you add here. No, don't add here. Here you should add. Where you should add? Where? Where you should add? Here you should add. Multiply. So now check. Again. Hydrogen 2. Done. Oxygen 1 into 2. Done. But here 2 into 2. What is this? 2 into 2. 4. Again here 2 into 1. Subscript is nothing, means 1. 2. Done. It's good. But again, in the case of hydrogen, we got a problem. So where shall I make it as 2 here? Into 2, shall I do it here? Shall I do it here? 2. Subscript you should not touch. Remember, subscript you should not touch. No, it's a wrong way. So where I have to write? Where I have to write? So 2 2 is 4. 2 1 is 2. 2 2 is 4. Done. Done. Okay. So balancing also have some steps. So what are the steps and how to do it? In the next video we will learn.